Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on high calorific value and low calorific value of the fuel. So first, what is the meaning of calorific value? Today's session we'll discuss about how to calculate the high calorific value and low calorific value of the fuel. So first, what is the meaning of fuel? So fuel is a combustible substance. During burning process in the presence of oxygen, it produces heat energy. So that energy is used for domestic and industrial purpose. That is called fuel. That process is called combustion. So now let's discuss calorific value. So actually calorific value means the efficiency of fuel. It can be understood by its calorific value. So the efficiency of fuel, it can be understood by its calorific value. So calorific value means it is defined as the total amount of heat. Total amount of heat liberated when a unit mass of fuel. So here unit means 1 kg or 1 gram or 1 part. So how much amount of heat liberated when a unit mass of fuel is burning completely. That is called calorific value. So how much amount of heat liberated when a unit mass of fuel is burned completely, that is called calorific value of fuel. So the efficiency of fuel, it can be understood by its calorific value. So the quantity of heat, that means calorific value. So it can be measured by following units. So that is calorie, kilocalorie, British thermal unit and centigrade heat unit. So the quantity of heat can be measured in this calorie, kilocalorie, British thermal unit and centigrade heat unit. So commonly used units are calorie and kilocalorie. So generally 1 kilocalorie is equal to 1000 calories. That is the relation between calorie and kilocalorie, generally used units for heat measured. So calorific value means how much amount of heat liberated when a unit mass of fuel is burned completely is called calorific value. So the efficiency of fuel can be understood by its calorific value. Common units of calorific value or heat measured in this common units are calorie and kilocalorie. So there are two types of calorific values. One is high calorific value and the other one is low calorific value. So what is the meaning of high calorific value? It is also called as gross calorific value. It is also called as gross calorific value. So how can we define this one, high calorific value? So it can be defined as total amount of heat produced. Total amount of heat produced when a unit quantity of fuel completely burned. And the products of combustion are cooled at room temperature. That is also we can consider. So how can we calculate the high calorific value or gross calorific value? So HCV equal heat liberated plus latent heat of vaporized water formed. So what is the meaning? How much amount of heat liberated when a unit mass of fuel is burned? That is called heat liberated energy. How much heat? So that is also considered, and also we can consider latent heat of vaporization of water formed. So that means completely burned and the combustion products are cooled at room temperature. So that temperature also we can consider for calculation of high calorific value. So HCV equal heat liberated plus latent heat of vaporization of water formed. So generally when a fuel containing hydrogen, for example, hydrogen present in this fuel. So during burning process, hydrogen is converted to steam. Hydrogen is converted to steam. So if the combustion product are cooled at room temperature, so in this case, if in case hydrogen present in this fuel, it convert to the steam. So when we cool at room temperature, so these combustion products are cooled at room temperature. In this case, the steam gets condensed into water. The steam gets condensed into water. So and latent heat is evolved. That heat is called latent heat. So thus, the latent heat of condensation of steam is also included in this gross calorific value. So HCV equal heat liberated plus latent heat of vaporization of water formed. So what is the meaning of lower calorific value or net calorific value? So total amount of heat liberated when a unit mass or volume of fuel is burnt completely. Here net calorific value exact we can consider only how much amount of heat liberated when a unit mass of fuel is completely burned, that is called lower calorific value. So here, so how can you calculate this lower calorific value or net calorific value? It's equal HCV minus latent heat of vaporization of water produced. We can eliminate this, we can remove from this HCV. So HCV, LCV equal high calorific value minus mass of hydrogen into 9 into latent heat of vaporization of water formed. So here, that means what is the meaning of mass of hydrogen into 9? Here in this reaction, for example, 1 part by weight of hydrogen. So 1 part by weight of hydrogen, it produces 9 parts by weight of water. 1 part by weight of hydrogen produces 9 parts by weight of water. So here, the latent heat of steam is 587 calories per gram. Just now we discussed already, if in case hydrogen present in the, generally hydrogen present in fuel. So during burning process in the presence of oxygen, hydrogen converts to the steam. So when we cool this combustion product at room temperature, in this case it evolves latent heat, that's value is 587 calories per gram. So how can you calculate a low calorific value? So it's equal HCV minus mass of hydrogen into 9 into latent heat of vaporization of water. Its value is 587 calories per gram. So NCV equal GCV minus 9 by 100 H into 587. This is the final formula. So or otherwise you can write GCV NCV net calorific value or LCV lower calorific value, it's equal GCV minus 0.09 H into 587. Here what is the meaning of H? Percentage of hydrogen present in fuel. And now discuss theoretical calculation of calorific value by Dulong's formula. So Dulong's formula for theoretical calculation of calorific value, these formulas are most important for calculation of high calorific value and low calorific value of fuel. So according to Dulong's formula, theoretical calculation of calorific value of GCV or HCV, gross calorific value or high calorific value, it's equal 1 by 100 into 8080 carbon, 34,500 H minus O by 8 plus 2240 sulfur kilocalorie per kg. This is a formula generally used for calculation of high calorific value. So here carbon, this hydrogen, oxygen and sulfur in this formula, this represents the percentage of corresponding elements in the fuel. The percentage of corresponding elements in the fuel. So it is based on assumption that the calorific values of carbon, hydrogen, sulfur are found to be 8080. So calorific value of carbon is 8080 and 34,500 and 2240 kilocalories when 1 kg of fuel is burnt completely. So for example, 1 kg of fuel burnt completely. So we can assume that the calorific values of carbon, hydrogen, sulfur are 8080 and 34,500 and 2240 calorific values. You can assume 1 kg of fuel is burnt completely. Here, all the oxygen in the fuel is assumed to be present is combination of the hydrogen in the ratio. So that's why you can write here. So hydrogen and oxygen ratio is 1:8. The 1 part by weight of hydrogen burns in the presence of 8 part by weight of oxygen. to produce 9 parts by weight of steam. So here, a hydrogen and oxygen you can take 1:8 by weight. So the hydrogen is available for the combustion is H minus O by 8. H minus O by 8 because hydrogen present in fuel during burning in the presence of oxygen it produces steam H2O. So we're going to calculate the percentage of hydrogen and oxygen, always H minus O by 8 formula we are using here. So how can we calculate the lower calorific value or net calorific value? It's equal HCV minus 9 by 100 H into 587 kilocalorie per kg or calorie per gram. So here 9 is the percentage of hydrogen present in fuel. Here H means percentage of hydrogen present in fuel. 587 is the latent heat of vaporized water and latent heat evolved in this process. Its value is 587 kilocalories per kg. So by using these two formulas, we can calculate the high calorific value and low calorific value of the fuel. These two are very, very important for numerical calculation purpose. So now let's discuss numericals based on this high calorific value and low calorific value. So here, what is the problem? Calculate the gross and net calorific values of coal sample having the following compositions. So what is that? Carbon is the 85%, hydrogen 6%, oxygen 2%, sulfur 3%, nitrogen 1% and ash 3%. So these are the following, these are the elements present in this fuel. So can now calculate the gross and net calorific values of coal sample. So here, what is the formula we are using for? We can use it for this high calorific value calculation. So HCV equal, just now we discussed already. So HCV equal 1 by 100 into 8080 carbon, 34,500 H minus O by 8 plus 2,240 sulfur. Here you can assumption that carbon, hydrogen, sulfur calorific values are 8080, 34,500 and 2,240 when 1 kg of fuel burned completely. So here carbon, hydrogen, oxygen, sulfur, these elements express that the person how much percentage present in this fuel or coal sample. So here carbon percentages, for example, we can substitute all the elements composition percentages in this formula. So here 1 by 100, 8080 into carbon percentages, here how much percentage present in this coal sample? 85%. So we can substitute here 85 and 34,500 into H minus O by 8. So what is the hydrogen percentage present in this sphere? 6. So we can take here 6 and O by 8. So oxygen percentage is 2. So here we are taking 2 by 8 plus 2,240 sulfur percentage here 3. So that's why we are taking here 3. So all the elements composition how much is present in this coal sample we can substitute in this above formula. So finally you'll get 1 by 100 into 6,86,800 plus 1,98,375 plus 6,720 calorie per gram. So here finally next step is 1 by 100 into 8,91,895 calorie per gram. So what is the high calorific value of this sphere? 8,918.95 calories per gram. Okay, what is the high calorific value of this sphere? HCV equal 8,918.95 calories per gram. Now we will calculate low calorific value or net calorific value. So low calorific value, its formula is LCV or net calorific value, NCV. It's equal LCV minus or HCV minus 9 into H by 100 or 9 by 100 H into 587. Here H is the percentage of hydrogen present in fuel and 587 is the latent heat evolved. So here, so HCV is the 8918.95 minus 9, H hydrogen percentage here 6%. So we can substitute in this formula 6 by 100 into 587. So here final get low calorific value is 8601.97 calorie per gram. So in this way you can calculate the high calorific value and low calorific value of the fuel by using these two formulas. One more problem we'll discuss about based on that high calorific value and low calorific value. So here a sample of coal contains carbon equal 60%, carbon equal 60%, hydrogen 6%, oxygen 33%, sulfur 0.5%, nitrogen 0.2% and ash is at 0.3%. So now let's calculate the high calorific value and low calorific value or net calorific values of the fuel. So what is the meaning of calorific value? So how much amount of heat liberated when a unit mass of fuel burning, that is called calorific value. So now discuss you can calculate the high calorific value. So high calorific value, what is the formula they are using here? So according to Dulong's formula, HCV equal 1 by 100 into 8080 carbon plus 34500 H minus O by 8 plus 2240 sulfur calorie per gram. This is the formula used for determination of high calorific value of fuel. Now you can substitute the these elements, how much amount of carbon, hydrogen, oxygen, sulfur present in this coal sample given in this formula. We can substitute that percentages in this formula. So finally get 1 by 100 into 8080 and carbon percentage is the 60 given in this formula. So we can substitute here carbon percentage is 60 plus 34,500 into H minus H percentage is hydrogen percentage is 6. Hydrogen percentage is 6 here given in this formula and minus oxygen percentage is here 33%. So we can substitute here 33 by 8 plus 2240 into sulfur percentage present in this coal sample is 0.5. So we can substitute here 0.5 calorie per gram. So here 1 by 100 into, so finally after calculation you get 4,84,800 plus 64,687.5 plus 1,120. Finally you get after substitution in this formula. So finally get after that 1 by 100 into 5,50,607.5 calorie per gram. So final HCV high calorific value of the fuel is 5,506.07 calorie per gram. This is the high calorific value of the fuel. And now discussed about, now you can calculate about low calorific value. So according to Dulong's formula, low calorific value or net calorific value, it's equal HCV minus 9 by 100 H into 587. So just now we discussed already, 587 is the theoretically latent heat evolved during this combustion product are cooled at room temperature. So this value is fixed 587 kilocalories or calorie per gram. So it's equal HCV value, just now we can calculate already. So HCV equal 5,506.07 minus 9 into hydrogen percentage given in this problem is 6. So we can substitute in this formula. So 9 into 6 by 100 into 587. into 587. So after substitution, we'll get 506.07 minus 316.98. 316.98. So finally, you'll get lower calorific value or low calorific value is 189.095 calorie per gram. So in this problem, we'll calculate the high calorific value and low calorific value by using Dulong's formulas of high calorific value and low calorific value. So here high calorific value is the 5,506.07 calorie per gram and low calorific value is 5,118.0.95 calorie per gram. So in this way, you can calculate the high calorific value and low calorific value of fuel. Now let's discuss one more type is like approximate analysis. How much percentage of volatile matter or moisture content and ash content present in coal sample. It is another type. In this coal sample, we can calculate the percentage of moisture content, volatile matter and ash content. So how can we calculate this percentage fixed carbon also? So how can we calculate this percentage present in coal sample? So what is the problem given here? A sample of coal weighing 1.98 grams. This coal sample weight is 1.98 grams. So on heating for 1 hour, at 110 degrees centigrade, for 1 hour. So left a residue weighed 1.78 grams. A residue weight is 1.78 grams. So the residue was heated in a suitable crucible with a lid at 950 degrees centigrade for exactly 7 minutes. Exactly 7 minutes. So the residue weight is 1.59 grams. So the residue was heated in presence of air till a constant weight was obtained. So this residue weight 0.231 grams. So now calculate the approximate analysis of coal. So already we discussed last class what is approximate analysis, how can we analyze, how can we determine the percentage of moisture content, volatile matter, ash content and fixed carbon. What is the significance, already we discussed in previous classes. So now let's discuss how can we calculate the percentage of moisture content, volatile matter, ash content and fixed carbon by approximate analysis. So here, so what is the use of approximate analysis? So it can be used for the determination of which coal fix the price and quality. So what is the use of approximate analysis? To fix the price and quality of coal. So that purpose we are using this approximate analysis. So here, so weight of the coal sample is 1.98 grams. So given in this problem, weight of coal sample is 1.98 grams. So weight of the coal sample after heating 110 degrees centigrade for 1 hour. After heating 1 hour at a temperature range is 110 degrees centigrade. So in this case, we can observe the weight. Again, we can calculate the weight of coal sample. So its value is given in this formula 1.78 grams. Starting we are taking coal sample weight is 1.98 grams. After heating for 1 hour at maintaining temperature range is 110 degrees centigrade. So in this case the weight of the coal sample is 1.78 grams. 1.78 grams. So now the difference in weight gives the difference in weight. That means before heating and after heating, the difference in weight gives moisture content of the coal sample. Moisture content in the coal sample. So now amount of moisture present in coal sample, it's equals 1.98 minus 1.78. So that means 1.98 is the total weight of coal sample taken first. And 1.78 means after heating 1 hour, you'll get the weight of the coal sample is 1.78. So the difference is 0.20 grams. So this is expressed as the percentage of, it is expressed as the moisture content of coal. So weight of the coal sample expressed as the moisture content in coal. So how can you calculate the amount of moisture content present in coal sample or percentage of moisture in coal sample? It's equal W1 minus W2, that means weight of coal sample after heating by weight of coal sample before heating into 100. So the difference is here we are taking 0.20 by weight of coal sample before heating is 1.98 into 100. So finally get 10.1 percentage. So the percentage of moisture present in coal sample, it's equal 10.1 percentage. 10.1 percentage. Now you can calculate the volatile matter present in coal sample. Generally, how can we calculate the volatile matter present in coal sample? So after computing the moisture content determination of the remaining coal sample closed with a lid, heating in muffle furnace. So in this case, weight of the coal sample is after computing moisture content, its weight is 1.78. So after heating in this with closed with a lid, because you can calculate here volatile matter. So close with lid and heating it electrical furnace. We are giving this heating it lid at 950 degrees centigrade exactly 7 minutes. So the weight is 1.59. So here before heating weight is 1.78 minus after heating 950 degrees centigrade for 7 minutes exact, you can get the weight of the coal sample is 1.59. So the difference expressed as the volatile matter present in coal sample, it's equal 0.19 grams. So initial weight of the residue is 1.78 grams and final weight of the residue of coal sample is 1.59 grams. So now calculate what is the formula we are using for determination of volatile matter present in coal sample. So percentage of volatile matter present in coal sample, it's equal, you can write here W2 minus W3, or you can write weight of coal sample after heating in step 2 by weight of coal sample into 100. You can use this formula also. So your weight of coal sample after heating. So you are take the difference between W2 minus W3. That means initial weight of the residue W2 and final weight of the residue is W3. So that's value is finally get 0.19 grams. So we can substitute here 0.19 weight of the coal sample after heating by weight of coal sample. Starting we are taking 1.98. Starting we are taking coal sample is 1.98 into 100. So finally get percentage of volatile matter present in coal sample is 9.60 percentage present in this coal sample. Now you can calculate the amount of ash present in coal sample. Amount of ash present in coal sample. So here also same. Initial weight of residue is given in this formula 1.59 inch after completing volatile matter. So what is the weight of coal sample? 1.59. It is a W3. And final weight of the residue is W4. Here 0.231 grams. So here constant weight which gives the ash content present in the sample. Here you cannot take a difference between that. You can take direct value of ash weight of the coal sample after heating. So amount of ash present in coal sample is 0.231. So what is the formula generally we are using? Percentage of ash present in coal sample. It's equal weight of crucible after heating in step 3. That means ash content determination. So weight of crucible after heating by weight of crucible before heating into 100. So here weight of the crucible after heating, what is the weight of this coal sample? 0.231. 0.231 we are taking here, and by weight of crucible before heating, so total weight of the coal sample is 1.98 into 100. So its equal finally will get 11.67 percentage of ash present in coal sample. 11.67 percentage of ash present in coal sample. So finally we'll calculate the percentage of fixed carbon in coal. Generally carbon present in coal, high percentage of carbon present in coal means it increases the calorific value, and we can consider as good coal. So good coal always contains high percentage of carbon because it increases the calorific value. So already we know that efficiency of fuel, it can be determined the percentage of calorific value or determination of calorific value. If in case high percentage of calorific value means it is considered as good coal. So how can we calculate the percentage of fixed carbon in coal? It's equal 100 minus percentage of moisture content plus volatile matter plus ash content. So here in this formula we'll get already it's equal 100 minus percentage of moisture content is 10.1. We calculate just now. Volatile matter is 9.6. Ash content is 11.67. So all these values you can determine just now, and the value substitute in this formula. So we get finally it's equal 100 minus 31.37. So it's equal 68.63 percentage of fixed carbon present in coal sample. So in this given according to data, so the percentage of moisture present in coal sample is 10.1 and volatile matter is 9.6 and ash content is 11.67. So the fixed carbon present in coal sample is 68.63 percentage. So in this session we'll learn about how can we calculate the high calorific value and net calorific value present in coal sample by using Joule formulas. And also you can calculate the percentage of moisture content, volatile matter, ash content and fixed carbon percentage present in coal sample by proximate analysis. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.